Hi everybody, welcome to my presentation. My name is Tsubasa Fukumura, and I am a graduate student at the Department of Engineering of Utsunomiya University, Japan. Today, I'm going to present a paper entitled An Efficient Learning Method for Sound Classification using Transfer Learning for Hammering Test. This is a collaborative study by Prof. Ito, Prof. Koike, Mr. Hibino, Mr. Kawamura, and Mr. Aratame. Mr. Hibino and Mr. Kawamura belong to both DENSHI Corporation. Before my presentation, I'd like to express the depth of my gratitude to our research team. They are doing many things which are innovative and helpful. We've also got so many people that we'd love to thank for their contribution to this research. This is the outline. First, I will explain the background and problems of the hammering test. Then, I will introduce about existing technology for the hammering test and this problem. Next, I will talk about our previous study using CNN to solve the problem. But the study also had a problem, so I will explain our study using transfer learning. Finally, I will describe our conclusions and future study. First, I will explain the background. In Japan, the aging of concrete and tile structures causes a serious problem. For example, in 2012, Sasago Tunnel had fallen about 130 meters, and 9 people were killed by the accident. Hence, the demand to investigate the damage caused by aging concrete or tile structures are rising. The hammering test is cost-effective and useful method for investigating the condition of concrete and tile structures. What is the hammering test? An inspector checks the flaking of the concrete and tile structure. An inspector hits the wall and tile with a metal rod, listens to the sounds, and finds the flaking parts. If there is a flaking part, the sound should be different from the normal parts. However, the hammering test has a problem. The effectiveness and efficiency of the test depend on the experience. It is required to develop a tool to support the hammering test for a not experienced person. Recently, there are many research to transfer skills to the next generation by using ICT, especially AI. Therefore, we decided to use machine learning to develop a hammering test support tool. I will introduce the existing hammering test support tool. This picture shows our hammering checker. The impact sound is received by a microphone, is analyzed by the gaming algorithm, and displays results by red and green LED. The accuracy is about 80%. This score is lower than our expectations. I will introduce the related work of the hammering test titled Clustering of Spatial Relevant Audio Data using Frequency Capstone for Diagnosis of Concrete Structure by Hammering Test. In this paper, the authors present a supervised learning approach to the automation of the hammering test for the diagnosis of concrete structures, among others. The accuracy is about 95%. But this research is about the hammering test of concrete structure, and we do not use this method because our research is about the hammering of tiles. As mentioned before, we try to introduce AI. We try to use a convolutional neural network instead of the Kami algorithm 3 years ago. We collected 2,321 training data and 702 test data. we normalize the sound data and use a fast Fourier transform. A learning model was created from the training data. After that, we tested with the model by the test data. The accuracy was 90.2%. This table below explains the hyperparameters for CNN. It has 2048 input nodes, 32 hidden nodes, 2 output nodes. The activation function is sigmoid, the optimizer is Adam, and the number of epochs is 20. This picture shows a hammer with a microphone to pick up the impact sound. This picture shows the tile test specimen used. The material of the tile is porcelain. The part of the red square is weakly bonded. The weakly bonded parts are like the flaking of tiles. This figure shows the waveform of the recorded sound. The power of the wave is normalized and mapped to -1 to +1 to make it easy to be handled on CNN. The performance of CNN was better than the K-mean algorithm, but this method also has a problem. In Japan, there are about 500,000 apartment buildings, and each building has a different surface of the wall and tile structures. So each building has a different hammering sound. To cover all the walls of the apartment building, we should collect the astronomical numbers of training data for CNN. If it is possible to run the features of each wall case by case, it is very convenient and we do not need to collect huge training data. In order to solve these problems, we tested the effectiveness of transfer learning. Transfer learning is a new machine learning technique by replacing a layer in the existing trained model to meet specific requirements. It is possible to create a new machine learning model with less training data by using transfer learning. We can also create a model in less time. Next, I will explain the hammering test using transfer learning. This figure illustrates the architecture of the proposed model. First, we hammer the wall and collect the sound data. Then, we split the data into training and test datasets. We remove the last layer of an existing trained model to obtain a modified model. We then train the modified model using the training dataset while preserving the knowledge from the existing trained model using transfer learning to obtain a new model. We evaluate the new model using the test dataset. A probability close to 1 indicates that there is flaking of the tiles. The model's output is binary. Its output is either good or bad. Good represents the strongly bonded part, and bad represents with the weakly bonded part. In this research, we use the Teachable Machine developed by Google provides an environment of transfer learning. The basis of this Teachable Machine is mobile nets. Mobile nets is a CNN model with 28 hidden layers. Teachable Machine is realized by replacing one layer of this model and learning again using new training data. We designed two patterns of trained models using transfer learning. The two patterns have different numbers of training data, and we call them experiment 1 and experiment 2 respectively in this experiment. Experiment 1 has 20 training data, and experiment 2 has 40 training data. We used the same recording device and tiled test specimen as our previous study. This table shows a comparison between transfer learning and CNN. The accuracy was 90.2% when we used CNN. In contrast, the accuracy of experiment 1 was 85%, which is less than the desired value. However, the accuracy of experiment 2 was 90% when we used 40 training datasets. The difference was only 0.2%. This result shows transfer learning used for conducting a hammering test on tiled walls. Now, I'd like to mention our conclusion. We proposed the hammering test model using transfer learning to detect strongly bonded and weakly bonded parts of tiles. Traditional deep learning techniques such as CNN require 2,321 training data points to achieve a prediction accuracy of approximately 90%, whereas our model requires only 40 training data points to achieve similar accuracy. Hence, by introducing transfer learning, it is possible to use the hammering test support tool at any type of wall of an apartment. In future studies, we will compare base models of transfer learning and adjust their hyperparameters to improve accuracy. Thank you for your listening, and please don't hesitate to contact us if you have any questions.